the reason why we find common denominators and lowest common denominators comes into play whenever we're adding rational expressions or subtracting them, which is what we're going to be doing in the next video. There's one basic rule for adding rational expressions. And that rule is, I'll put a little bit more space there. That rule is if you have a over b plus c over b, that's the same thing as a plus c all over b. So that means, for example, if we have, say we're trying to add these two fractions, 2x plus 7 over x plus 3 plus x plus 2 over x plus 3. So we're trying to add these two. So we use the basic rule for adding rational expressions. If our denominators are the same, then we can just add across. We have a over b plus c over b, so we have a plus c all over b. Here we have the same denominator, so we can go ahead and just add across. We add the numerator and we add the numerators together, and then put it all over the denominator. So that means this will be the same thing as 2x plus 7 plus x plus 2 all over x plus 3. In this particular case, we do not need to put parentheses around this, but when we get to subtracting, you'll see that it will be important to put parentheses around these right here. But at any rate, now we have this plus this, and we have it all over the same denominator. And then we can go ahead and combine like terms. 2x plus x will make this 3x. So this 2x and this x combine to make 3x. This 7 plus 2 is going to combine to make 9. Then we have over x plus 3. And then we think, okay, is there any way that we can simplify this? Whenever you're done with a question that involves fractions or rational expressions, think, is there any way that I can simplify this? Well, in this case, we can. The first thing to simplify rational expressions is you want to factor out the top and the bottom. Can we factor this out? There is actually a there's a common factor to all of these, so we can factor out a 3 to all of these terms. I mean, we can factor out a 3. So we will get 3 times x plus 3. So I just factored out a 3 from these two right here. 3 times x plus 3 all over x plus 3. Now we think, are there any terms that we can cancel? Yes, there are, because we have a common factor to both the top and the bottom. We can cancel this x plus 3. So this whole thing equals 3. Now, of course, your answer is not often going to, in fact, it's going to very rarely turn out to be just a simple number. But in this case, you have these two rational expressions that when you add them together, simplify to make just a number. So, let's go ahead. That's all well and good if you have denominators that are the same. But what if your denominators are not the same? That's why lowest common denominators are so important. We use lowest common denominators to make our two fractions, or our two rational expressions, be the same. So I have 3 examples of here, and all of these, just so you know, I don't know what the answer is yet, because I'm working these out. I wrote them down, and I don't know how they're. I have an idea of how they're going to end up. I chose these specifically because I think I know how they're going to end up. But I wanted to go ahead and do this all by ear. Not by ear, by... I don't know what the expression I'm looking for is. I'll just try to do this as I go along, I guess. Part of the reason why I fill up time with with talking things like that is because I'm usually doing it while I'm typing something out long like that. So we have x plus 2 over x squared minus 9 plus x minus 3 over x squared plus 6x plus 9. Okay, so we want to go ahead and add these together. I'm going to move this to the top so that we have just this example showing. So the first thing we want to do is find the lowest common denominator. And to find the lowest common denominator, we want to factor out everything that we can. Can we factor out this x plus 2? No, we can't. That's as far as it goes. Can we factor out this x squared minus 9? Sure, that's going to be x plus 3 times x minus 3. Because this is the difference of two squares. X squared is a square, and 9 is a square. So we can separate that. We can factor it out to x plus 3 times x minus 3. And then we have this right here. What is this? Well, this turns out to be a perfect square. We have a square term here, x, and a square term here, 9. 2 times x times 3, because x is the square root of this, 9 is the square root of this. 2 times x times 3 gives us 6x. So this turns out to be x plus 3 quantity squared. So I'm going to go ahead and rewrite that out as using those factorizations. So we'll have x plus 2 over x plus 3 times x minus 3. So x plus 2 over x plus 3 times x minus 3 plus x minus 3 over x plus 3 quantity squared. So I just factored these two denominators out. That's all I did. And now I try to find the lowest common denominator. I'm going to do that. Get a little bit more room. I'll do that up here. So so that doesn't look quite right. Denominator. Okay, so we want to find between these two lowest common denominators. We want to find out all the factors and how often they occur. So what are the factors? Well, we have an x plus 3. We have an x minus 3. Put this too high. And then we have an x plus 3, but we already have an x plus 3. And that's the last one. So what's the most that the x plus 3 occurs? It occurs at most twice. Because it occurs twice here and once here. 2 is bigger than 1, so it's 2. And then for this next one, x minus 3, we need to figure out what the exponent for that is. It occurs once here and no times here. Once is bigger than nothing, so the exponent remains 1, and we can keep that hidden because a to the power of 1 is equal to a, and to substitute that in, we'll have x minus 3 to the power of 1 is equal to x minus 3. Point being that if it only occurs once, you don't need to make a point to write the exponent. So we have a LCD of x plus 3 squared times x minus 3. So we need to rewrite these fractions, these expressions, so that they have the same denominator. So let's go ahead and I'm going to write these down over here. X plus 2 over x plus 3 times x minus 3. So what is missing from the denominator that would give it this as the denominator? Well, the only thing that's missing is 1x plus 3. So I'm going to go ahead and multiply that out. We'll have x plus 3 over x plus 3. So that way, when we multiply that out, we'll have x plus 2. Doesn't look much like parentheses, does it? X plus 2 times x plus 3. I'm not going to multiply these out just yet, but I will in just a minute. Right now I'm only concerned about getting the denominators to be the same. X plus 3 times x plus 3 will give us x plus 3 quantity squared times x minus 3. So now we have the denominator is the same thing as this up here. The point being that now we're on our way to getting this denominator and this denominator to be the same. If that makes sense, hopefully. So we multiplied this by what's top and bottom of this by what it's lacking to get this. See, if we multiply this by the x plus 3, then we will get the x plus 3 squared times x minus 3. Now let's do it to the other one. So we have x minus 3 over x plus 3 quantity squared. What's lacking? The only thing that it's missing that would give it the lowest common denominator of the LCD is the x minus 3. It already has two x plus 3's. So we multiply top and bottom by x minus 3. Which will give us x minus 3 quantity squared over x plus 3 quantity squared times x minus 3. Okay, so now we have two expressions that have the same denominator. They both have x plus 3 squared times x minus 3 as the denominators. I'm not going to multiply all that out. First of all, that would take forever, but it's also unnecessary, at least at this point. I'm also not yet going to multiply these two parts out or this part out. I will in a minute, but at this point in time, it's not necessary. So I'm going to go ahead and rewrite this, except type it out. Then I'm going to erase all this. Not because this is unimportant, just because it's taking up room. So this then will equal this x plus 2 over x plus 3 x minus 3 is equal to this. So it's going to be x plus 2 x plus 3 over x plus 3 quantity squared times x minus 3, x plus 3 quantity squared times x minus 3, and then plus x minus 3 quantity squared. So this second part is just going to be this rewritten, x minus 3 quantity squared over x plus 3 quantity squared times x minus 3. Okay, so I know that this is written on top of that, but I want to go ahead and double check it before I clear all this stuff off. So x plus 2 times x plus 3 over x plus 3 quantity squared x minus 3. X minus 3 squared over x plus 3 squared times x minus 3. Okay, now I'm going to go ahead and clear off all of this stuff here. So, now we have two fractions that we're adding together that have common denominators. This is why we unsimplify. This is why we write these fractions in ways that we could simplify and make easier to understand if we wanted to. So, let's go ahead and do that. So we just add across. So we will have this equal to x plus 2 times x plus 3 plus x minus 3 quantity squared. So I just added these across, x plus 2 times x plus 3 plus x minus 3 quantity squared, all over x plus 3 quantity squared times x minus 3. I have people that constantly, I've seen this a lot. I will see people that will add the top and add the bottom. That's not the way it works. That works for multiplication, not addition. So whenever you add two fractions, you need to make sure that the denominators are the same, If they're not, then you make them the same. Then you add across, and the new fraction will have the same denominators that the two fractions that you had just before did. Okay, so now we go ahead and we multiply this top part all out. We never really need to multiply all this stuff out. This x plus 3 quantity squared, we can if we want to. If we want to be completely technical, then the most simplified form of this fraction in the end will have this all multiplied out. But right now, it's just a complete waste of time. So we're going to just leave it like that for now. And maybe in the end, we'll see that something could be canceled. We don't know yet. I don't know yet because I don't know how this is going to turn out. So next, I want to go ahead and multiply this out. Think of it as FOIL, or as I like to think of it as visually. So x squared plus 3x plus 2x plus 6. So that's, this part is just this part. And x minus 3 quantity squared will give you x squared minus 6x minus plus, 9, because it's a perfect square. So x squared minus 6x plus 9 is this right here. This stays exactly the same. In fact, I'm just going to copy paste it. X plus 3 squared times x minus 3. So now I'm going to clear all that off. Now I want to combine like terms. So I can have a x squared and an x squared. So x squared plus x squared. That'll give me 2x squared. So we'll have 2x squared. And then I'm crossing. Ooh, I forgot to put the equal sign. Okay, so now I'm going to cross this off, not because I'm canceling them. I'm crossing them off because I'm done with them. I've already combined those like terms, and I don't want them to get in the way of the terms that I haven't combined yet. So now I can combine this 3x, 2x, and negative 6x. Don't forget there's a negative in front there. So 3x plus 2x will give us 5x. Minus 6x will give us minus x. So 3 plus 2 minus 6 will give you 5 minus 6, which equals negative 1. So I'll give you negative x. Then you have this 6 plus 9. So then we have 6 plus 9 will give us 15, plus positive 15. All over the same thing. I wonder if it's okay, all over the same thing. Okay, now let's see, is there any way that I can factor this out? I don't even know, so I'm going to do it over here. So if we have 2x squared, okay, that's going to be 2x plus, I'm just doing guess and check here, 2x plus, I'm going to say 5 and 3, 5, and then x plus 3. I know that these two things, the first term and last term, are going to be right. I know, oh, it's going to have to be minus. I'll go with this minus. I know that it's going to have to both be minus. So that leads me to think that it's not going to be able to factor out. But I'll figure it out for sure in a minute. So, yeah, that can't be factored out any further. So we'll just stick with that, because I'm the reason why. Here, I'll go ahead and guess and check this just so you can see. This will be 2x squared minus 6x minus 5x. See, they both have to be minus because this is plus, and this is minus. So this is going to give us negative 11x. So that doesn't work. Then we can mix this up, 2x minus 3 x minus 5. This will give us 2x squared minus 10x minus 3x plus 15. This is negative 13x, so this doesn't work. Let's see, I'm going to run out of room. Here, I'm going to move this up, and oops, let's erase that. Okay, so now I'll go ahead and try instead of 3 and 5, 15 and 1, and maybe you can see now why this isn't going to work. So you have 2x squared minus 2x minus 15x plus 15. This is going to give us negative 17. That's lazy. Negative 17x. So that will not work. Switch it out. 2x minus 1 times x minus 50. Wow, that is bad writing. 2x minus 1 times x minus 15. This will give us 2x squared minus 30x minus x plus 15. So 2x squared. Maybe this was unnecessary to take this much time to do this, but I just realized I was going to make this into a really long video. So this does not work, and we've tried every single possible combination of 2x of the things that might work. So none of them work, and the reason why I realized that can't factor out any further is because there was no way to combine two things that are greater than 1. You can't add two things that are greater than 1 and get something that's 1. And it's the same thing here. That's why I knew that wasn't going to work out. At any rate, that means then that this, let's go ahead and, is going to be the final answer. Okay, so I just realized that was just the first example, so this video is going to be pretty long, but only because of how long the examples are. So let's go ahead and go on to the next example. And that's going to be x over 2x squared minus 3x minus 2 plus x over 4x plus 2. So x over 2x squared minus 3x minus 2 plus x over 4x plus 2. First thing we want to do is to find the lowest common denominator. To do that, we need to factor every individual piece. X and x, of course, you can't factor that any further. So we want to figure this out. This 2x squared minus 3x minus 2. I'll have to do that with guess and check. So 2x is going to be a plus and a minus because you have this minus here. There's only two things that can combine to make. There's only one combination of numbers that you can multiply to get 2, and that's 1 and 2. So I'll do 2, 1 here. So this will give us. I will know that will not work. The reason why I know that will not work is because if it did work, then you could factor out a 2, which means that you could factor 2 out of this whole thing. So I know that will not work. So 2x squared minus 4x plus x minus 2, and this turns out to be right because that's minus 3x. So this will factor out to 2x plus 1 times x minus 2. Okay, so this is the factor form of that. How can we factor this at all? We can, because there's a 2 common to each of these. So we'll have 2x plus 2. I just factored out a 2. That's the greatest common factor. So we can say that this whole thing is equal to x over 2x plus 1 times x minus 2 plus 4x. Oh, x over 4x. Crud! I just forgot to Okay, 2 times x plus 2. Okay, so I just factored each of these individual parts out. 2x plus 1 times x minus 2, and 2 times x plus 2. Okay, so now let's go ahead and clear all that off. And now we can need to figure out what the lowest common denominator is. I'm going to go up so I have more room this time. So the lowest common denominator of this right here, well, it's going to have each of these factors. It's going to have, whoops, oh my gosh, I'm so glad I caught that. That's a 2, I don't know what I just wrote for that, but that should be 2 times 2x plus 2, not 2 times x plus 2. I'm not sure what I just wrote here because it's cleared off, but when you factor a 2 out of this, there will be a 2x plus 1. Did it wrong again. 2x plus 1. I realized now what I did. I mixed up the 2 and the 1. Okay, so when you factor a 2 out of this, this will be 2x plus 1. Okay, so now we are looking for the lowest common denominator. If we weren't looking for that, I would not have caught that mistake. So we have a 2x plus 1 as a factor. We have an x minus 2 as a factor. We have a 2 as a factor. This 2 does count as a factor. And we have the 2x minus 1, but we already have a 2x minus 1. So what are the powers? Well, this 2x minus 1 occurs at most once. It never occurs more than once. So it occurs once here, and it occurs once here. So that means we have the power of 1 here. This x minus 2, how often does that occur? It occurs once here, it does not occur here. That means it occurs at most once, so it has a power of 1. This 2 occurs once here, no times here. That means it has a power of 1. So let's go ahead and go to the next line and rewrite these using multiplying by what's missing. So what's missing from this one right here? In fact, I'll go ahead and do this down here first. For the x over 2x plus 1 times x minus 2, what's missing from the denominator that would give it the greatest common denominator? Only one thing, 2. So we multiply top and bottom by 2. And here's the divider here. What's missing from x? That didn't look like x. What's missing from x over 2 times 2x plus 1? That would give us that would give it the denominator that's the same as the least common denominator. Only one thing, x minus 2. So now I'm going to go ahead and rewrite these, but with the common denominator. So this 2 times x will give us 2x, and this 2 times all this stuff, I'm just going to rewrite this. I'm not going to multiply all this out, so I'll just make it 2 times 2x plus 1 times x minus 2. So 2x over 2 times x plus 1 times x minus 2 plus x times x minus 2. I'm going to have to multiply that out in a minute, but not right now. Over 2 times 2x plus 1 times x minus 2. So I just multiply the top and bottom of this one right here times by x minus 2. So now, once again, I have two rational expressions that have the same denominators. Now, this one, then, is equal to this one, and this one is equal to this one. Except that now, these two have common denominators, whereas these don't. So, I'm going to go ahead and clear all that off. And now, we can combine these. Now I'm going to add and distribute this x at the same time. So we're going to have 2x plus x squared minus 2x. 2x plus x squared minus 2x. Okay, and now that's all over 2 times 2x plus 1 times x minus 2. So now we can have 2x minus 2x. Those two things will cancel each other out because you add them together to get 0x. So you will get x squared over 2 times 2x plus 1 times x minus 2. Oops. Okay. X squared over 2 times 2x plus 1 times x minus 2. So that is as simplified as you can possibly get, because you can't factor this out and there's no x's down here. So that means that this is going to be the final answer. If we wanted to, if we had a calculator, we could check these by putting random numbers in for x and then evaluating it and seeing if it turns out the same here as it does here. I'm not going to do that now, but just so you know, if that interests you at all, you could do that. Okay, so we have one more example. And that example is x minus 1 over x plus 1, x minus 1 over x plus 1 plus x plus 5 over x squared plus 4x plus 3. Okay, so the first thing I want to do, of course, is factor out everything I can. There's only one place to factor anything. That's down here. So this is going to be equal to, it's going to be x plus 1 times x plus 3. So, I'm going to go ahead and rewrite this as x plus 1 over, sorry, x minus 1, I skipped ahead to something else. X minus 1 over x plus 1. This first fraction doesn't change. Plus x plus 5 over x plus 1 times x plus 3. Okay, so I just factored out this second thing into this. So we look for the lowest common denominator. The only thing that, I'll just go ahead and do it like this. We have an x plus 1. It occurs at most one time, because it occurs once here. Greatest of those is 1. And we have at most one x plus 3. It occurs no times here and one time here. 1 is greater than 0, so this is going to be the lowest common denominator. So on the next line, by on the next line I just mean down here instead of on here, we can go ahead and multiply top and bottom of this by x plus 3. So we'll have x minus 1 times x plus 3 all over x plus 1 times x plus 3, and then plus x plus 5 over x plus 1 times x plus 3. So, I've got to put the equal sign in front. I guess it's kind of implied, but even so, it's best to go ahead and have it. So now we have this in the form where we can go ahead and add them, because they have the same denominators. So, but before we do that, we want to go ahead and multiply this all out, because that'll make this part easier. But you know what? I'm going to go ahead and do that in the same step. I'm going to multiply this out and add these at the same time. It's really not that difficult. It's just a bit of a time saver. So this is going to be equal to x times x will give us x squared. X times 3 will give us plus 3x minus x minus 3 plus x plus 5. all over x plus 3 times x plus 1 times x plus 3. So now we want to combine all terms that we can. So we have exactly one x squared term, so there's nothing to combine it with. We have this 3x, we have this negative x, and we have this positive x. So this negative x and positive x will cancel out. You'll have minus 3x. Then you have this, so we're done with these terms here. We have this negative 3 and this plus 5. So we'll have minus 2. And so then we're done with this. We actually finished with that a long time ago too. So x squared minus 3x minus 2 all over x plus 1 times x plus 3. So we've added the two fractions by now, but we want to go ahead and see if there's any simplification that could be done. So we do that by factoring this out and seeing if there's anything that can cancel. So this would factor out as x, oh, whoops, this should be plus 2. So here, I'll erase this and we can see why. So x minus 3 plus 5, that should be plus 2. So I'll go ahead and fix that. Okay, so that's good to know that that should be plus 2. So we can factor that out to x minus 2 times x minus 1. Because negative 2 and negative 1 multiply to make positive 2 and add to make negative 3. So this is x minus 2 times x minus 1. Huh. I think I wrote down the wrong problem. Either that or I did something wrong, because I actually meant to have this come out as plus 1. So, alright, well, so that should be plus, oh my gosh, what did I do here? This should be plus, another mistake. These two things canceled out, leaving a positive 3x, not negative 3x. So sorry about that. So that should be, here, I found it in the code, plus 3x. Gosh. Okay, so that means that these two things are going to factor out as x plus 2 times x plus 1. Okay, so I actually created this problem hoping that it would that this x plus 1s would cancel out, and they do. So on the next line, let's go ahead and rewrite this using the factored form. So it's going to be x plus 2 times x plus 1 over x plus 1 times x plus 3. Now we're getting somewhere. Now we can simplify because we can cancel the x plus 1s. The bottom x plus 1 cancels with the top x plus 1. So we'll end up with x plus 2 over x plus 3. X plus 2 over x plus 3. So that is our final answer. And that concludes this particular video. The subtracting rational expressions video is going to be hopefully quite a bit shorter. I spent a long time on the examples for this. I don't even know how long this video is going to end up being because I don't watch the clock when I make these. Alright, I will see you in the next video.